Hey guys, so these are examples 9 and 10 from the notes for today. So the first one is example 9. So mine might look a little different than yours. My printer ran out of ink, so I just wrote it on paper. So it says, write the equation of the new function g of x given each transformation, then graph f of x and g of x on the same coordinate plane. Okay, so our g of x is 3f of x. So it says if f of x is x squared, what is the equation of g of x? So if it's out front, it means it's happening to the whole thing, which means I need to put the same 3 out front of this function. So g of x is actually going to be a 3 times everything that f of x was. So x squared. Okay, I don't actually need these parentheses because it's just 3 times. So my actual g of x function is going to be 3x squared. And when there's a 3 out front, that right there is a vertical stretch by a factor of 3. Okay, it's vertical because it's outside the x, so anything in front or behind it's going to be vertical, and anything inside the parentheses with the x is horizontal. Okay, so it's a vertical stretch by a factor of 3, so it's vertical because it's out front, and it's a stretch because 3 is bigger than 1. Okay, so any number bigger than 1 is going to be a stretch. So after I figured out this part, so this is the new equation it's asking for. If you needed to write the transformation in words, that's what it would be called. Okay, then it says, then graph f of x and g of x. So I'm going to make g of x blue, and I'm going to make f of x pink. Or in the original problem on her notes, it was red. So the original f of x is right here. This is the original one. So that's just x squared. That's a parabola, that's the U shape, and everything is centered at 0. So in your calculator, you can use your calculator or do it by hand. I'm just going to use the calculator. My table function, x squared, enter, 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 enter. So I'm putting everything around 0, 0, because if you look at it, it goes 0, 1, 4. And if I look over here, 0, and then it goes 1, 4. So that's where it starts repeating itself. Okay. I also know that 0, 0 is the vertex because this isn't moved anywhere. That's what we call the parent function. Okay, parent functions are what everything is based off of. Okay, so this right here has a vertex of 0, 0. So I'm going to put my 0, 0, which means my axis of symmetry is also going through that 0. So everything I have on the left should also be the same on the right. So based off of my table, I'm going to graph negative 1, 1, negative 1, 1, negative 2 is 4, negative 2 is 1, 2, 3, 4. Okay, and if I look on the right side, 1, 1 should be a point right here, and 2 should be, what was that, 1, 2, 3, 4. Okay, those should also match, so let's look over here. 1 is 1, perfect, and 2 is 4. So let's make those points. Okay, remember, these are all U shapes. So try and connect the dots. Oh, I kind of missed one. It's okay. To be a U shape. Okay, so next we are going to do g of x. So g of x is 3 times all of these. Okay, so let's plug it into the table. So we can see what it looks like, 3x squared. Okay. So also, there are no numbers in here with the x or outside. So this vertex is also at 0, 0. Okay, I can see that because in the table, so my table just starts at 0. It goes 0, 3, and then 12. If I scroll up, it goes 0, 3, and 12 up as well. Okay, so that's where it repeats itself. So wherever it starts repeating itself, that's where your vertex is. So I'm going to draw that down on top. Okay, so let's see. 1 is at 3. 1 is at 1, 2, 3. And -1 is also at 3. Then let's just go to -2. -2 is at 12. Oh, sorry, you can't see that. -2 is at 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's all the way up there. Yours only goes to 10, so just put a dot somewhere up on top. Okay, and then 2 is also up there at 12. Okay, so let's see if I can connect these. Okay, so that's what it should look like. So I took each of these points. So this was, let me label this one. This was 1, 1. And then this one became 1, 3. My other pink point was at 2, what was that? 1, 2, 3, 4. And now I'm up here at 2 stayed the same, but the 4 became a 12. I multiplied it by 3, just like here. See how 3 is being multiplied? Okay, so that's your first example. The next one, see if I can go down some. Okay, example number 10 has the same exact directions, write the equation and then graph, but this time it's in words, okay? And there's multiple things happening here. So again, we're assuming the function is still x squared, because that's everything we're working on. All of these are parabolas, they're all the U shape. So if it's a reflection across the x-axis, that's going to be represented by a negative and it's going to go out front. Okay, shifted left 3. This is a horizontal shift left 3 because if you think about the x and the y axis, this line, I go left and right. Think about if I'm walking, I can walk to the right, I can walk to the left. This is a horizontal line, right? It's like the horizon, right? The sun sets and rises. It's the horizon, okay? So it's horizontal. And it's shifted to the left. So since this is on the x-axis, it's going to be with the x. I'm just going to put a little x. And it's left 3. Everything with the x is opposite. So left actually means you're adding 3. So that's going to show up as x plus 3. Okay, then shifted up 4 units. Okay, up and down is this y. Okay, and that's vertical. So this should actually say a vertical shift up 4 units. And vertical stuff happens on the outside. That's going to be a big plus 4 on the end. So my g of x, now we're going to put it all together. My g of x has to be an x squared. Okay. We said my x, though, is an x plus 3. So x plus 3 squared. The plus 4 is a big plus 4 on the outside. And we can't forget about that negative. That negative just goes in front. Okay, so reflected across the x-axis means if you're a happy face, you're not going to be a frowny face. Okay, whenever something's negative out front, it's a frowny face. So I'm going to graph the pink again first. And then my blue is going to be the g of x. So again, this is going to be the exact same function we graphed here. Okay, is what I'm doing down here. Come on. Can you see that? Okay, so just like before, I had 0, 0, 1, 1, and then looking up here, I had 2, 1, 2, 3, 4. 2, 4. Okay, and I'm just using the same exact points I had above. Negative 1, 1, negative 2 was 4. Okay, and I know it's at 0, 0 because this is called the parent and it wasn't moved anywhere. All parent functions are going to start at 0, 0. Okay, now I need to graph this. Okay, a lot has happened to this. However, your vertex is going to stay the same. So I'm going to write down my vertex. My vertex is the opposite of x. So it's going to be a -3, keep k, keep 4. So -3, 4. Opposite always. So opposite, keep. Opposite, keep. The negative, though, is going to tell me my graph needs to be facing downwards. Okay, remember this means it's facing down. It should look like that. It should be a frowny face. So the first thing I'm going to do is I'm going to plot my vertex, -3, 4. 1, 2, 3, 1, 2, 3, 4. Okay, and I'm also going to draw my axis of symmetry because when I do this, it should be the same on both sides. Okay, so then I'm going to use my calculator again like I did before. Turn it on. Go to my table function, clear that out. Negative goes first, and make sure you're using this negative button, not the minus sign. Okay, so a negative, parenthesis, x plus 3, parentheses squared, squared, plus 4. So, and now, let's just say we started. So I'm still going to show that it starts at 0, but I really don't want to start at 0. I want the middle of my table to be where my vertex is. So I'm going to go up to -3. -3 is at 4, and that's perfect because it matches. So the points I'm going to graph, I'm actually going to make a little table so you can see it. I'll write it right here. Okay, so when I do my table, x, y, I want the middle of my graph to be my vertex. Okay, so this right here is my vertex. That's going to be in the middle. I'm going to choose 2 points before it and 2 points after. So -3, so then -4 is smaller and so is -5. So -4 is at 3 and -5 is at 0. Now I'm going to go down. -2 is at 3 and look, it matches, which means -1 should be at 0. And look, it is. Okay, if you want your y-intercept, just go down one more, 0. So 0, -5 is your y-intercept. I'm not going to put that on the graph for right now, though. Okay, so let's plot these points I have. I already have my vertex. Let's do the left side. -4 is at 3. Oh, y'all, I plotted this wrong. I did -3, -4. I'm like, why isn't this working? I plotted that wrong. -3 is up at 4. I went down. Sorry, guys. -3 is 1, 2, 3, 4. There we go. That makes sense. So I knew I was wrong because as I was looking at to plot this, it would have been going up, right? And I need to go down. So I fixed my vertex. It is now -3, +4. Just can't count, y'all. This is what happens when you don't get enough sleep. So -4 is at 3. So -4 is at 1, 2, 3. -5 is at 0. Hey, look, it's a solution. Okay, look, this guy's a solution. And so is this guy. Solution. Okay, if you were ever asked. Solution, x-intercept, 0. There's another word we use and I can't remember. Okay, so those are solutions. So now I'm going to do the other side of my axis of symmetry, which is -2 is 3. And look, it matches. Okay, and then, let's see if I can see it better.